In this video, we are going to discuss about uh, more problems on Z parameter. So the first question is determine the Z parameter for the following network. So here the three resistance are given. Their values are 10, 20 and 15. Okay, so this is your I1 value and this is your I2 and this is V1 and V2. Okay, so what is the current that is flowing through 15? That is I1 plus I2. So according to the mesh 1, I can write V1 is equal to 10 I1 plus I1 plus I2 into 15. So what is V1? V1 is equal to 25 I1 plus 15 I2. This is your V1, and accordingly I can write what is Z11. Z1 is equal to 25 and Z12 is equal to 15. What is V2? V2 is equal to 20 I2 plus 15 I1 in plus I2. So that is equal to 35 I2 plus 15 I1. So from this I can write Z21 is equal to 15 and Z22 is equal to 35. Okay. So if I form a matrix that is Z11, Z12 and Z21 and Z22, that is equal to 25, 15, 15 and 35. Okay. So in this you can see there is no dependent source. So 10 plus 15 is 25 and 15 is between V1 and V2, so it is Z11 and Z12 and Z21 is equal to 15. Okay, so next problem, determine the Z parameter of the following network. So this the circuit looks similar, but you can see in addition to this T network, I have added one dependence current source. Okay, that is it is in the shape of diamond. So that is I1. So the current flowing through this one is I2 and this is V2. Okay, so if I want to find the value of Z11, what is Z11? Z11 is equal to V1 by I1 for I2 is equal to 0. Okay, so next in order to find the value of Z21, what is Z21? Z21 is equal to V2 by I1 for I2 is equal to 0. Okay, so the dependent source, you can have a dependent source in this type of networks. Okay, so I have to redraw the circuit. So I have to redraw I have to substitute I2 is equal to 0. Okay, I'm going to redraw this one. Thereby I am going to substitute I2 is equal to 0. Okay, so if I2 is equal to 0, let's see what will happen. Okay, according to the Kirchhoff's current law. So this is your I1 and this is 5, and so if you see the I2 is 0, so this is V2 and this is V1. Okay, so what is the current flowing through this one? It is I1, right? Because according to the current law, right? So this is 2I1, right? This is also due to Kirchhoff's current law. So for the mesh 1, I can write V1 is equal to 10 I1 plus 2 into 2I1 into 5. So this is nothing but 20. So what is V1 by I1? Z11. So that is equal to 21. Okay. So Z parameter is also called as impedance parameter. So next I need to find the value of Z21, right? So Z21 is V2. Okay. So what is V2? So you have to go for this loop. So I can write V2 is equal to 10I1 plus 2I1 into 5. That is also equal to 20I1. So what is V2 by I1? That is Z21, that is equal to 20. So next we need to find the parameter value of Z21 and Z12 and Z22, right? For I1 is equal to 0. So what is Z22? Z22 is equal to V2 by I2. For I1 is equal to 0 and Z12. Okay. So is it 1, 2 is equal to E1 by I2 and I1 is equal to 0. Okay. So now I'm going to draw the network for I1 equal to 0. Okay. So this is I1, that value is 0. So this is I1, and I'm going to substitute the resistance value and okay, plus 5, and this is I2, and this is weight, right? So I can write V2 on this way. So according to the current law, this is I2, right? So what is this one? This is also I2. Okay, according to the Kirchhoff's current law. So I2, V2 is equal to 10 I2 plus 5 I2. That is 15 I2. So V2 by I2, that is Z22 is equal to 15. Oh. Next, what is V1? V1 is equal to 0 into 10 plus 5 8, right? So what is V1 by I2? V1 by I2 is at 1 2, that is equal to 5. So here also you can write it the Z parameter in form of matrix. So I can write Z11, Z12 and Z21, Z22 is equal to 20, right? 20, this is 5 and 15, right? So it is not symmetrical, and it is not also, this is also reciprocal. Okay, this network. Okay, this is the conclusion. We will also discuss in another problem. Okay, like pi network. Okay, I hope the second problem is clear, and let me go for the third problem. So this is also determination of Z parameters only. So this the network. Okay. So it is nothing but pi network. Okay. So since it is in the shape of pi, that is 22 divided by 7. So their values are R3, R1 and R2. Okay, so the current flowing through this one is I2, and this voltage is V2 and current flowing just on I1 and V1. Okay, so this is nothing but a pi parameter, pi network. Sorry. So first we need to find the value of Z11 and Z21, right? So what is Z11? That is V1 by I1 for I2 is equal to 0. So first let us substitute I2 is equal to 0 and the current is IA. So this is according to the Kirchhoff's current law, this is I1 minus IA. Okay. So what is now IA according to the current divided rule? Okay. First let me write V1. V1 is equal to R1 into I1 minus R1 into IA, right? Next we need to find the value of IA. IA is equal to I1 into, that is total current, into R1, opposite resistance, right? So this is nothing but a current divider rule. Okay, R1 divided by R2, R1 plus R2 plus R3. Right, so we substitute the IA value in the above equation. So you will get V1 is equal to R1 I1 minus R1 I1 R1 divided by R1 plus R3 plus R2. Okay, so you can take I1 common and divide the I1 on both sides. So you will get V1 by I1. Right. So what is V1 by I1? V1 by I1 is Z11. So if that is the case, you can see that R1 plus R2 plus R3 are to bring it to the numerator, and the whole term get divided by R1 plus R3 plus R2. Okay. So you can see the pi network has a it is reciprocal and it is also symmetric. So this is what we are going to identify in this problem. So and also in the forthcoming video we are going to discuss how to find the reciprocity and symmetry. Okay, so V1 by I1 is equal to R1 into R1 plus R3 plus R2 minus R1 square divided by R1 plus R3 plus R2. So here R1 square minus R1 square get cancelled out. So I can write R1 into R3 plus R2 divided by R1 plus R2 plus R3. Okay, this is the value of Z11. Okay, so next to find the value of Z21. Okay, what is Z21? Z21 is nothing but V2 by I1 for I2 is equal to 0. Okay, so what is V2? V2 is equal to IA into R2. Okay, so V2 is equal to IA into R2, and you need to substitute the value of IA. What is IA? IA is equal to I1 into R1 and divided by R1 plus R2 plus R3 into R2, right? That's the numerator. So you can write V2 by V1, that is equal to Z21, that is equal to R1 R2 divided by R1 plus R2 plus R3. Next I need to find the value of Z22 and Z12. Right, so that is V2 by I2 for I1 is equal to 0. So for I1 is equal to 0, you have to read out the equation. Similarly for Z12 is equal to V1 by I2 for I1 is equal to 0. So let us draw the network. So here I1 is 0, right? So first let me draw the pi network. R3, R2, R1, and this is I1, that is 0. V1, this is I2, and this is V2. So let me term this one as IB. Okay, so this is nothing but I2 minus IB, right? According to the Kirchhoff's current law, because if I add, I will get the answer as I2. So I2 is my overall current. So V2, I can write it as V2 is equal to I2 minus IB into R2. That is equal to I2 R2 minus IB R2. Okay. So what is IB now? IB is equal to total current is I1 into opposite resistance R2 divided by R2 plus R1 plus R3. Okay. So I substitute in the above equation. So V2 is equal to I2 R2 minus I2 R2 square divided by R1 plus R2 plus R3. So what is V2 by I2? That is, if I take the numerator to the left hand side, okay, numerator to the left hand side, you will get the equation like this. So here R2 square and minus R2 square get cancelled out. So Z22, that is equal to V2 by I2 is equal to R1 plus R3 into R2 divided by R1 plus R2 plus R3. Okay. So next Z12, that is equal to V1 by I2. So what is V1? V1 is IB into R1 divided by I2. So you substitute the value of IB. IB is equal to I2 into R2 R1 divided by R1 plus R2 plus R3 divided by I2. So I2 get cancelled out. So R1 R2 divided by R1 plus R2 plus R3. That is here Z12. Okay. So from this you can check the values of symmetry and reciprocity. Okay, you can see Z21 is equal to Z12. So it is reciprocal, right? So next you can compare the value of Z11 and Z22. So Z22 is equal to R1 into R2 plus R3 divided by R1 plus R2 plus R3. So this value is similar to that of Z11, right? You can see. So this network is symmetrical also. Okay.